6.3. Perform function operations in composition. A power function. A power function is in the form y equals a x to the b, where a is a real number like 2 or -3 or a half, and b is an exponent. We'll skip composition here for a second, and let's look at operations. Let f and g be any two functions. A new function can be defined by performing any one of the four basic operations on f and g. So if f of x is 3x and g of x is x plus 3, then if we want to add them together, we just add 3x and x plus 3 to get us 4x plus 3. Simple. If we want to subtract them, we do the same thing. Notice though that we had to put the x plus 3 in parentheses because it's going to change the sign in here. So 3x minus x is 2x, and then minus 3, because I had to use the distributive property. Multiplication, 3x times x plus 3 is 3x squared plus 9x. And then division is 3x divided by x plus 3. The domain of H consists of all the x values that are in the domains of f of x and g of x. Additionally, the domain of the quotient does not include values for which g of x is 0. So if we look up here, we can't put a -3 in here, because if we have a -3, we would be trying to divide by 0. So this domain would not include -3. Okay, example 1. Add and subtract functions. Find the following: fx plus gx. So we need to add them together. So here's the solution down here. 3 of something, and then -5 of something. We can go ahead and have the 3 minus 5. So that would be -2, and then we have to keep the of something here. And so that would be our answer. Now if we're going to subtract it, same thing, except it's going to change the sign. 3 minus a -5 would be 8. 3 plus 5 to x to the 1/2. And remember, x to the 1/2 is just square root of x. So now what are the domains for them? What's legal to put in for a square root? Well, any positive number, right? Or 0. It can't be negative. So we need to say all non-negative real numbers. So the domains of the addition and the subtraction also consist of all non-negatives. Okay, example 2. Multiply and divide them. Okay, fx times g of x. So that would be 7x times x to the 1/6. So remember that we can go ahead and put a 1 up here, and we add the exponents together when the bases are the same. So that would be 7 times x to the 7/6. And then b, we're going to divide them. So 7x over x to the 1/6. Well, you don't really want to leave a 1/6, a fraction, on the bottom. So let's go ahead and subtract the exponents. Put our 1 up here again. So that'd be 7x to the 1 minus 1/6. And that'll equal 7 times x to the 5/6. Now, where are its domains? The domain of f is all real numbers. Because if you look up here, what's legal to put in for x there? Everything, positives, negatives, just not anything imaginary. Now, how about g of x? Okay, that's a root again, and it's an even root, so we need the all non-negatives. So if we're going to multiply them together, we need to make sure it's all the numbers that are in both domains, so it would be all the non-negatives. Okay, on f divided by g, what's the domain? All positive real numbers. Because we can't have a 0 in there, because if we put a 0 in right here, that would be dividing by a 0. So we can't say all non-negatives this time because that includes 0. We just need all positive numbers. Okay, go ahead and do this checkpoint, and then we're going to skip the little picture here and go to the next page. Start the video again when you're done. Okay, example 3. Find compositions of functions. Composition is where we're going to stick a function inside of another function. So anytime we see the x, we're going to actually put in parentheses the second function. And you know how to do this by looking at what they give you. So they start with f here. So we're going to start writing out f. And so here's f of x, 6. And then I'm going to leave a big spot for the x and put the -1 here. Now inside of f, where the x was, is g of x now. So I'm going to stick this g of x where the x was. Okay? And then I'm going to simplify it. So remember that the -1 means flip it underneath. And so that would be the composition of those two functions. Now, let's do it the other way. They have g of x on the outside now. So I'm going to start with g of x and say 3, and then where the x is, I'm going to leave a spot, plus 5. And then I'm going to stick the f of x inside my parentheses here, 6x to the -1. Then I'm going to simplify that. So 3 times 6 is 18. And then the x to the -1 goes on the bottom. And then the 5 goes out here at the end. Okay. Now I'm going to put f of x inside of f of x. So let's start writing 6, leave a space, to the -1, and then put 6x to the -1 here. That looks a little complicated, doesn't it? So let's pull this -1 inside to both numbers, and that would be 6 to the 6 to the negative 1, and then x to the, what's negative 1 times negative 1? That's positive 1. And then that would be 6 times 1 over 6. That just crosses out, doesn't it? And so we're just left with x to the first, or just plain x. Now, domain-wise, what up here can we not put in for x? What would make that 0 on the bottom? Negative 5/3, right? So we cannot put negative 5/3 in for that a, because g at negative 5/3 is 0. And we can't divide by 0. It's in the domain of f. Note that f of 0 is 6 over 0, which is undefined, can't define and divide by 0. The domains of g of f of x and f of f of x consist of all real numbers, except where x is 0, because 0 is not in the domain of f. Okay, there's a checkpoint at the bottom. Go ahead and do that one.